Ooh, what if you get something like this? Is it in standard form? What do you need on the side with the constant? What do you need that constant to be for it to be in standard form? It needs to be 1. Remember, the standard form that we use is x squared over a squared plus y squared over b squared equals 1. We have to have a 1. We have a 36. What could we do? Divide everything by 36. And then it does reduce nicely here. On the right side, you do get 1. And then the 4x squared over 36, you can think of the 436 as reducing to what? Yeah, 1x squared, or just x squared over 9 plus what? Y squared over 4. And then, is that the same as what no, it's not quite the same as what we just had. So the center is still 0, 0. How far left and right do you go to graph this thing? 3 again, right? I think it was 3 in the last one, yeah. So left and right, 3. 1, 2, 3. 1, 2, 3. Up and down, how far this time? 2. Oh, so it's going to be stretched out horizontally this time, isn't it? It's going to be longer horizontally than it is vertically. Good enough. Oh, you know what the difference is here? I'll show you a trick. So same idea, right? We have 6x squared plus 16y squared equals 16. Not quite in standard form. So what would you do to get it in standard form? You need that 16 to be a 1, right? And if you simplify that, you get 6. Okay, well, okay. Technically, I guess what does 6 over 16 simplify to be? 6/16 reduces to 3/8. That's not quite in standard form. Plus, well, this one's good, right? 16y squared over 16. That's just y squared equals 1. It's still not quite in standard form. So, look. The standard form actually looks like this. Centered at 0, 0, it's x squared over a squared plus y squared over b squared equals 1. So why isn't this in standard form? You got to have a 1 in front of the x squared on top, right? And we have a 3. So this is a very useful trick. And it looks weird the first time you see it, and then you think, well, why didn't I ever think of that before? So you can think of this, couldn't you think of this as 3/8 times x squared? 3x squared over 8, isn't that the same as 3/8 x squared, first of all? Same thing, right? So I'm multiplying 3/8 times x squared. Okay, you know how you guys have used this a lot in your life. When you divide by a fraction, you flip it and multiply. It works the other way around. When you multiply by a fraction, you can flip it and divide. You're just not used to going in that direction. So in other words, multiplication by 3/8 is the same as division by 8/3. And if you rewrite it using that simple trick, it's in standard form then. Multiplying by that 3/8 is the same. Think about it. If you go the other way, then it's obvious, right? You're dividing x squared by 3/8. Oh, or 8/3 rather. That's the same thing as multiplying by 3/8, isn't it? It works both ways, though. You've probably never used that trick in this direction, though. But what does that allow us to do? So the idea is this guy, 8/3, is a squared. So by writing it this way, all we have to do is take the square root of that thing, and we get an idea of how far left and right to go from the center. Remember, to figure out how far left and right you go, you take the square root of the number underneath x squared. Well, that's not as bad as it looks. I mean, what's the square root of 8/3? Just get an estimate for it. Second function square root of 8 divided by 3. It's about 1.6. The square root of 8/3 is about 1.6. Now, you don't see it, but what's the denominator of y squared? 1. Or you could think of it as 1 squared if you like, right? Okay, so how far left and right do you go from the center? 1.6, so no, not very far. 1.6 right about there. I could either scale it differently or make the graph paper bigger. So I'm just going to make it bigger. So you're going to go left and right 1.6 up approximately, right? And then up and down 1. Oh, I probably should have rescaled it, but I didn't. So you get this picture. Or redraw it over there. There you go.